Dear learner, a warm welcome to this session of the course of PCB Design and Fabrication Lab. In this session, we are discussing on graded exercise 11. It is about design a 8051 development board having a reset and input-output sections. We'll directly move into the KiCad design software. Now double click on KiCad software. Go to File, click on New Project. Type name of the project under your folder. So I'll type as a MC experiment. Click on Save. So in order to do the schematic design, clicking on the schematic layout editor. So new window will be open for the schematic circuit diagram. So now you can place a various symbol. So in order to design microcontroller development board, first of all you need to create symbol of the microcontroller 8051. So you can create a symbol of the microcontroller 8051 using symbol editor window. So I already created a microcontroller 89C51. So I'll get it from my symbol library. So click OK. So you can place the microcontroller symbol here. So this is a symbol I had already designed. It will be in my symbol library. Now get the component like reset. For reset, I'll be using push button switches. So get switch push for the reset input. You can rotate now by using pressing on R key. Okay. Now use capacitor, get unpolarized capacitor now. So place here unpolarized capacitor. Okay, fine. Now get the resistor. Get the component resistor. So now we need a crystal oscillator. We need external crystal. So get the component symbol crystal, 2-pin crystal. Okay. Rotate the crystal component by pressing on R button. Now get the capacitor. So you can copy the capacitor. Okay. Get new capacitor. Rotate vertical. Place the component. Now place another capacitor. Rotate it. Place it. Next, between pin number 40 and pin number 20, we need a capacitor. So I'll connect here. Next one, we need a connector, 8-pin connector for all the 3 ports, P2, P3 and P1. For port 0, we are connecting external pull-up resistor. Now get the connector component. So I'll get component connector. So 8-pin connector. So place it over here. Place the component. So copy it. Place parallel to the port 3. Same copy. Rotate the component using pressing R. Yes, you can place it. Now get the resistor network. So resistor network, Click on register network. So get register network in the 8 register. Click on 8 register network. Okay. So place it across the port 0 now. Yes. Now we need a power connection. Connect component symbol VCC. Get component VCC. Now connect here. The same connection will be given to the pin number 40, which is the power supply pin for the 8051 microcontroller. Now get ground pin. Place component ground here. So I think we had placed most of all the component required for our application. So we had connected crystal, we had connected a push button switch. Now place wire to interconnect the all the component. Okay, start connecting the component. Copy, cancel, copy the component only. We'll copy only the ground. So place it over here, then connect wire. Get another ground. Now place the wire, connect to the crystal. To the crystal we are connected the capacitor, right? So this is the connection. Okay, next pin number 40, connect to the capacitor. Pin number 20, which is a ground pin of the microcontroller 8051, so it will connect to the ground. Next power supply required for the pin number 40, so we will connect. So now connect the all the component. Okay, connection will be done. Now the 3 pin will be unconnected, so use no connection flag here. Next we should use a symbol called power flag to indicate a power supply is from outside the circuit. So get power flag. Okay, place power flag here. Copy. Yes, we need to copy VCC. Rotate. We need to copy ground. Copy the ground also. Okay, symbol ground copy. Yes, now connect using the wires. Yes, all the connection is done. Now annotate clicking on the annotate schematic. Okay, now annotate. So annotation is complete. Okay, close. Now you have to perform the electrical rules check. Clicking on the perform electrical rule check. So now run. So it will showing that there will be a error. So where is that error? We'll see. So error is that it is not connected. So we need to connect to the VCC. So connection. So connect to the VCC pin. Yes. Now check. Save it. Now check is there any electrical rule check. Okay. So I'll delete marker. Then clicking again on run. So no error list. So message will be finished. Okay. Now next step will be assign PCB footprint to this schematic symbol. So click on assign PCB footprint to schematic symbol to assign a footprint for the symbols. So it will take some time to load the footprint library. So you have to load footprint for the symbol you add used in the case of the schematic design. So you have to see the particular data sheet, then only you will decide what is the footprint you need to include it for the symbol you had used in the circuit. Okay, so it will now load the symbol name. Now we have to assign the footprint. Okay, now assign the footprint for the capacitor C1. So capacitor C1, which will we have to assign the footprint by using the capacitor THT. To get capacitor THT under capacitor THT. Now we have to get the component disk capacitor footprint. Okay, I'm choosing a diameter of 7.5 mm and the pitch will be 5 mm. Thickness will be 5 mm. Capacitor. Same capacitor I'll be selecting for the all the four capacitor. Now I have to select a connector for a 8-pin connector. So I'm selecting the connector pin header. So now I'll be selecting 8-pin connector footprint. So pin header will be 2.54 with 1 cross 8 with the vertical connection, which will be 2.54. Select. So I'll select for all the 3 8-pin connector and selecting the same pin header. Okay, now select the resistor. So I'll select the component footprint for the resistor. Go to the resistor THT through hole component, then get axial resistor with the length will be 6.3 mm and pitch will be 10.16 mm. Next get pull-up resistor. Already it will be selected, so you can view this pull-up resistor on this footprint resistor. You can view pull-up resistor 3D view also. You can view the pull-up resistor. Okay, already it will be selected. Now I'll get push button switches. So go to the button switches, button switch THT. So get push button switch with the 6 mm. So I'll selecting the push button switch. Next get a 8051 microcontroller IC socket. So we'll get IC socket on package underscore DAP. Okay, search for package. Package underscore DIP. Okay, get the 40 pin IC socket for microcontroller 8051. So select 40 pin IC socket. So IC socket, I'll select 40 pin. Yes. Next one, crystal. So go for the crystal, then select footprint of the crystal HC49, HC49 4H vertical. Select the footprint. Okay. After selecting all the footprint, okay, based on the data sheet of the component, now click on apply, save schematic and continue. Click OK. So next step is to save the netlist file. So click on generate netlist. So it will ask whether we are saving under default file name. So generate netlist, save under default file name, my exp, save it. So next step is to going for the PCB layout design. Now we are moving to the PCB layout design. Go to tool, update PCB from schematic. So now PCB layout window will be open. Now click on the update PCB from schematic. Okay, netlist update is successful. Okay, now proceed. Now we'll move on to the this footprint inside the work area. So now the first step is to placement of the component. So now we have to place the component as per our design. Okay, so keep on move the component as per your requirement. So I'm moving the component capacitor, so crystal. So I'm moving here, then I'm placing the push button switch, moving the push button switch. Okay, yes. So you can rotate as per your requirement. Okay, now place all the component as per your requirement. uh, Capacitor C3 and capacitor C4 will be placed near to the crystal oscillator. Rotate, move or rotate. Okay. Move the component. So next one, I'll place a capacitor C1. Move resistor R1. Resistor R1, now capacitor C2. move registers, sorry, connectors. This is a pull up register. Next, placement of connector to the port 1. Next, place the pull up register. See whether all the components are properly placed as per your design requirement. The next step will be making the connection. That is called routing the track. So in order to change the track width or track size, so you have to go to the edit predefined sizes. Click edit size. I'll be adding the new size as a 0.4 mm. Click on OK. So now I'll start connecting the various component on back copper. Select root tracks. Okay. Now connect the component. Start connecting all the component by using the track. Now connect. So root all the connection. Yes. Now connect for the connector. Now connect the pull up register another end, common end to the VCC. Yes. Again 8 connections are remaining. Connect. Now the last connection. Yes, here unrouted will be 0. Yes, all the connection is okay. Do this connection again. So I'll take a ground connection. Okay, fine. Now save it. Now provide outline for this PCB layout by using a edge cut. Click on edge cut. Now add a graphics line. So it is used to make outline for the PCB layout. Yes. Now check for design rule check. Is there any violation on designing the this PCB layout? Save it. Click on perform design rule check. Run DRC. Yes, there will be no error as your PCB layout is done. Now you can view this 3D view of the PCB layout on 3D viewer. So this is how your PCB layout will look like. Okay. So next, in order to fabricate this PCB layout, you have to go to File and get the printout. Get print. So get the print preview. So then you can get the printout of the this PCB layout on glossy paper. Then you can fabricate this PCB on manual method. Okay, right. I think this is about how we can do the PCB layout. So you can here you can name the this PCB board by clicking on the text button. So now I'll select the back copper. So now you can name. So it is a microcontroller input output section. Okay, so this way you can name the component or board in the PCB layout. Okay, this is all about making a PCB layout as well as the schematic for the microcontroller development board with the input output section. Thank you for watching this session. Thank you one and all.